Alright, class, I want to go over some of the problems that I asked you to do yesterday. These rounding numbers problems, there was 48 of them, but what made this assignment unique was that I had asked you to look over some information I gave you in terms of some new rounding rules. Now, just very briefly, typically we would go with two rounding rules. Number one, if the number to be or the number behind the number to be rounded was less than 5, you round down. If it was 5 or more, you round up. That was rule 2. What we did, or what I want you to do, is include a third rule here. All right. And just briefly going over them. 0 through 4, you round down. So there's no difference in that rule. 6 through 9, you'll round up. Okay. If 5, then there are two situations we have to look at. All right. If the number that we're looking to chop off, the first number we're looking to chop off is a 5, we look at the number to the left of it, and we ask ourselves, is that number in front of the 5 even, or is it odd? If it's even, we round it down. And if it's odd, we round up. All right. That's a very, very short summation of the rules. Go back and look at the videos and the notes that I posted for you yesterday. If you want or need a more detailed explanation of that. Okay. Let's get rid of that. And let's take a look at, let's say, problem number 1 from our homework. 2.16347 times 10 to the 5th. And the problem asks us to round to 4 figures. All right. Well, let's take a look. All right. For sig digs and for rounding, we really don't even have to worry about this times 10 to the 5th part. All right. So just ignore that. The front part of the number, the mantissa as it's called, has, in this case, 6 significant digits. 6 sig digs. Right, remember, all non-zero digits are significant, so we count them all here. But we want to round to 4, and it's the first 4, so it'll be boom, 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 boom. And we're going to cut it off right here. Except we just don't cut them off. We have to look at the first number that we're cutting off, the 4, and apply rounding rules. All right. The first rounding rule is 0, 1, 2, 3, 4. We round down, which really means we keep it the same. So the answer would be 2.163 times 10 to the 5th. Right? Even though we don't really look at this to determine rounding or sig digs, make sure you put it back on the answer. Otherwise, it will be wrong. All right. How about number, let's see. Let's try number 3. 3.682417. We want to round it to 4 sig digs. Well, what are the significant digits? Well, they're all non-zero, so they're all significant. Every single one of them is. 1, 2, 3, 4, 5, 6, 7. 7 sig digs. right? We only want the first four. 1, 2, 3, 4. So we're going to cut it off here. Again, this is rounding rule 1, 0, 1, 2, 3, 4. We round down. So, in fact, we'll just get rid of those. The 2 remains a 2, so it'd be 3.682 would be the answer to number 3. All right. Let's try number 5. 375.6523. All the digits in this number are significant because they're all non-zeros, so there's really no debate there. All of them are significant. 1, 2, 3, 4, 5, 6, 7. This number contains 7 significant digits, but we're asked to round to the first 4. 2, 3, 4. So we're going to cut it off right there. All right. Now, take note that the first digit that's being cut off is a 5. So we're going to follow the rule for 5. And what was the rule for 5? We look in front of the 5 and ask ourselves, is that number odd or even? If it's even, we round down. So the 6 remains a 6, in other words. So the answer would be 375.6. Okay. Take a look at look at number 8. All right. 25.631. Right. Every single one of these digits is significant because they're all non-zeros. The instructions for problem 8 says to round to 2 sig figs. Well, that means the first 2. So the 2 and the 5, and then we're going to cut off the 631. However, the first digit we're cutting, the 6, would follow the rule 2 for rounding, which is if the digit here is a 6, 7, 8, or 9, we round the previous digit up. So 25.631 becomes 26. All right. Now, take a look at number 9. 40.523. Number 9 has got to be the hardest problem on this whole sheet. All right. First of all, we want to round to 2 significant digits, so that means the 4 and the 0. In this case, the 0 is significant because it's between 2 non-zeros. All right. 1, 2, 3, 4, 5 significant digits. They're all significant, but I want only the first 2. All right. What's the first digit I'm cutting off? It's a 5. What's the rule for 5? All right. And that is that we look at this number and we ask ourselves, is it even or is it odd? Now, for our purposes, we are going to assume 0 is going to be an even number. All right? And what's the rule for an even number? Round down. All right? If it happened to be an odd number, we'd round up. All right? But we're going to round down. Well, round down really means leave it the same. So that means our answer in this case would be just 40. All right? Is our answer. However, when we take a look at it, and if I were to ask you how many sig digs in that number, you would have to say only 1. Right? Only the 4 is significant. You have to go back and look closely at the sig dig rules. Trailing zeros that are to the left of a decimal point are not significant. All right? You could also use the Atlantic Pacific rule. This would be, let's see, the decimal point is absent. All right, so I would use the Atlantic rule, which means I'd come in from the Atlantic side and start counting sig digs only when I hit the first non-zero, which would be the 4, and that's it, 1 sig dig. But the instructions say to round to 2 sig digs. So how do I make that 0 significant? There's 2 ways. You just put a decimal point on there, in which case now it does become a significant digit, and now I have 2 significant digits, my answer. However, the preferred method of doing this is to convert it into scientific notation, right? And when I do that, I get 4.0 times 10 to the first. Remember, for changing the scientific notation, we move the decimal point, so there's 1 non-zero digit in front, so I'd have to go from here to there, 4.0, and since I moved it 1 place to the left, the exponent is a 1, a positive 1. So really, that is the best way to answer that one. Okay. Let's try, let's see, number 18. The instruction here for 18 is to round the number 2.473 to the nearest 0.1. Well, 0.1 is the 1/10th place. That's what 0.1 means, tenths place. So I'm going to take the significant digits I have, the 2, the 4, the 7, and the 3, and round it off to the 10th place, which is to this digit right here. So I want to count off, or cut off the 7 and the 3. Well, the rule for rounding with the 7 is to round up, so this will be 2.5. So that's your answer for number 18. Okay. Number 21. 1.3511. The instructions here for number 21 say to round to 1 decimal place. All right, that would be to right here. So that means I want to cut off the 511. I don't care about the ones. I'm interested in the first digit I'm cutting off. So that being a 5, I have to apply the rule for 5. What is the rule for 5? The rule for 5 says look back at the digit in front and just observe whether it's odd or even. In this case, it's odd. What's the rule for 5 when the number in front is odd? You round up. Right, so the 1.3 becomes a 1.4. Which is the correct answer for number 21. All right. How about number 30? 7.555. And the instructions are to the nearest 0.01. What does 0.01 represent? That 1 is in the hundredths place, so I want to round off to the hundredths place. I want to round off to the second decimal place right here. So that means I want to cut off this last 5. All right, now don't let all these 5s confuse you. It's only this last 5 right here that tells me I need to use the rule for 5. All right. If the digit here were 0, 1, 2, 3, or 4, I would round down. If it were 6, 7, 8, 9, I would round up. But if it's 5, it's special. So I say it's the rule for 5. What does the rule for 5 tell us to do? It tells us to look at the digit in front here and ask ourselves, is it odd or even? In this case, 5 is an odd number. And what's the rule for 5 when you have an odd number up front? Round up. So this 5 becomes a 6, and then I'm done. Correct answer here would be 7.56. Okay. Let's try another one. 34. 41.5 0.86632. The instruction for 34 says round to the nearest 0.001. In that number 001, that 1 is in the thousandths place. So we're being asked to round to the thousandths place, to this number right here, which means you want to chop off the 3 and the 2. Now this is pretty easy. All right, we look at the first digit we're getting rid of, which is the 3, and when this number is 0, 1, 2, 3, or 4, we round down. So we go back here and say the 6 remains a 6. I'm done. 41.866 is the correct answer to number 34. Okay. Let's try number 36. Same rounding request, and that is to the thousandths place, to the 0.001 place. 0045. Whereas the thousandths place, it's the third position after the decimal. Tenths, hundreds, thousandths. Anyway, we want to get rid of the 5. Alright, so that means we're going to be using the rule for 5. If the first digit we're getting rid of, in this case the only digit we're getting rid of is a 5, then we have to use the rule for 5. What does the rule for 5 tell us to do? It tells us to look at the number in front of it and ask ourselves, is it even or odd? Well, 4 is an even number. What is the rule for 5 when the number out front is even? It's round down, which really means leave it alone. Keep it the same number. So that will give us an answer of 0.004. Right. Had this 4 been an odd number, let's say it was a 7, then we would have said, okay, this number is odd, so we're going to round up. So it would be 0.008 would be the answer in that case. When we have the rule for 5, sometimes we round down, sometimes we round up. When we round down because this number in front is an even number, like in 36. All right. If it happened to be an odd number, then we'd round up. Okay. Let's see. Let's try number 41. 63.541. The instructions for 41, we're asked to round to the nearest whole number. That means to the nearest ones place. All right, to the nearest whole number, to the ones place. So that means we want to cut off the decimal portion, the 0.541. All right. What's the first digit we're getting rid of? It's a 5, so we need to use the rule for 5. What is the rule for 5? The rule for 5 says, look at the number in front of the 5. In this case, the 3. And ask ourselves, even or odd? Is it even or is it odd? In this case, it's odd. What is the rule for 5s when the number out front is odd? It is to round up. So we would end up with a 64. Now just a quick word here about this rule for 5. Okay, if this number out front is even, we leave it alone. We round down, in other words. So if it's even, we leave it even. All right, if it happens to be odd, we're going to round up, and if we round an odd number up, we're going to get an even number. So in essence, another way of stating the rule for 5 is make the number in front of it even. If it's even, leave it alone. If it's odd, round it up and make it even. That's often how you'll see the rule for 5 stated. Again, the rule for 5 is the number in front, make it even. There you go. And one more here. Number 44. Interesting. 5.396. The instructions here is round off the farthest right digit. So that means get rid of the 6. Alright. So we want to chop this off right here. Right? What do we do when the first digit we're rounding, or that we're getting rid of, is a 6? Well, we round up. So the number in front, the 9, has to become a what? A 10? Well, when it's a 9, what I typically do is expand my the digits I'm looking at. Instead of saying I'm going to round a 9 somewhere, I'm going to round a 39 up to the next number, so that would become 5.40. Okay, there you go. Now, just real quickly, how many sig digs in this answer? 1, 2, 3. Trailing zeros to the right of a decimal point are significant. All right, go back and look at your sig dig rules. Okay, later on today, I'll be posting all of the solutions to these problems that were assigned yesterday. If you didn't get this done, get it handed in quickly. As soon as I post answers, any late assignments then take a 40% penalty hit.